Hey everyone, today we are going to look at LeetCode problem number 523 contiguous subarray sum. So in this question we have been given a nums array and a k, and we need to find a subarray such that the sum of the subarray is a multiple of k. So if we look into this example, you can see we have this 2 and 4, and 2 and 4 is 2 and 4, the sum of 2 and 4 is 6, and we have this 6 here also. Another example we are having is k equal to 6, and like if we'll sum all of the elements, like we'll get 42, and 42 is a multiple of 6. And if we'll see here, this in this example we are having k equal to 13, but I mean we can see like 6 and 7 can form 13, but since it is not contiguous we will return false. There is one more condition in this question which they are asking, that is like if we have been given a k as 23, and you can see like we are getting 23 here, but we want at least two elements to sum up to be a multiple of k. So this is the condition. And there is one more thing, uh, that we have been given is that we can have 0 a multiple of k. So if we are talking about this 0 0, and we have been given k as anything, it can be anything. So this is also a multiple. So we have to take consideration of this also. And if we are talking about 24, like it will be just 24, then it is false, as like I mean if our k is 24 and we have been given 24 only, then like this is not possible, so we'll return false in that case. So how we can proceed for this part? So in this question we have been asked to find the contiguous subarray, and we know like we can find the contiguous subarray, like this is one subarray, then this is one subarray, then this is one subarray, then this is one subarray. After that we have this subarray, then this, then this, and after that we have this and this, and after that we have this. So we can do one thing, we can generate all the subarrays and check if k is equal to, like it check if that is a multiple of k or not. So we can do that, and obviously like it will give us time limit exceeding, but like you can see this is the code for that. We are just adding all the subarrays in the sum, and we are at the end we are just checking whether it's divisible, whether it's a multiple of k or not. And if it is, we'll just return true, otherwise we'll just return false, and it will pass uh, most of the test cases, but like we'll get TLE because like this is not efficient. The complexity is O of n square. So how we can optimize this? So what we are going to do in this problem is we will be using the prefix sum. So the prefix sum of this array will be this one, and if we'll divide all the elements by 6, you will get these things. So this will be the result after dividing it by 6. These are the mod values, and what we can observe here is we can see like we are having 5 multiple times, and we have 0 also. So if we are having 0, then that means that this is completely divisible, and we can return true in that case. But what about like some cases? So we can look at that. So let's see, let's pick these two fives. So if we'll pick these two fives, and like it's starting from here till here, and in between like we can see we are having this 2 and 4 here. Then if we'll pick these two 5 and 5, then it will be here, and we can see that we are getting this 6 here. So you can see we are getting 5 and 5 here, and why we are concerned about this 5. So let me give an example. For example, if we are having 20, and if we'll divide this by 6, then we'll get 5, correct? So what about if we'll add 6 in this, and then what will be the answer? So the answer will be 29 by 6, which is again 5. So what about if we'll add 12 here? So again the answer will be 35 divided by 6, which is 5. So you can see, so we can you can see we can add any multiple of 6, and again we'll get the same mod, which will be 5. So is that helpful in our question? Yeah, definitely, because we need to find a subarray whose sum is 6, and we can see like we were getting 5 here, then after some time we are getting 5 again. So that means in between there is some subarray which is having a sum of k. So now we got some idea that we can use these modulus values. So how we can solve this further? So what we'll do, we'll take a hash map and we will store all the modulus values in our hash table. So we'll have 5 at the 0th position, then we'll have I1 at the first position, then again we'll have this 5. So but 5 is already here, so we won't override this one. What we'll do, we'll check. So what we'll do, we'll just check when we have received this 5 last time. And if that value will be greater than or equal to 2, then that means like we are having a subarray. So in this case you can see uh, our ith pointer is 2 and we have received this at 0, so it is greater than equal to 2. So what we'll do, we'll just return true. if if for one example, like if for some case instead of this 5 we are having 8. Let's take one example, and in that case like we are having 5 for the first time in here at the second position. So we have received this 5, and at 5 3 like we are again getting this one, like at this position we are getting again 5. So what we need to do, we need to check the ith pointer is 0 1 2 3. 3 minus 2 is greater than equal to 2 or not. So it is not. So in this case we won't return our answer as true because like it's the single value. So let's see how we can code this problem. So in this problem what we are doing, so in the code what exactly we are doing, we are taking this hash map first to store all of our modulus values, and at first position we'll have this 5. Then at 5 we'll like what we are doing, we are just first thing we are doing is we are storing the modulus value in our hash map. This is the first thing, and if that value is already there, if this value is already there, we will compare the first time we have received. So this is the code to put if that is like to insert that one. if if it's already present we won't return that, so we can use this map.if. So this will take care of that. And if we are having this element again, like, so at that time what we will be doing, we will be comparing the last time when we have received this, and we'll just subtract the I with the last time. So it will be 1, so it will be 2 minus 0. So 2 is greater than 1. So this will be true, then like we'll return the true. It will return true. So this was the code, but like what exactly is this condition what we are checking here? So there might be a possibility that we will receive this 24 only. So at that time we'll just check whether our I is greater than equal to 1 or not. And we can have one more example which is 0. So at this case also, like this is only one element, and you can take care of this by this, and I've submitted that and it was accepted and it was pretty efficient also. So see you in the next video.